Alright, so all those videos cover everything about the mean axis and axis deviation. It's a pretty good video and it explains how to find the mean axis and axis deviation on an example that I got from the internet. In any and also just Google example of just Google mean axis practice or axis deviation practice, and they'll give you a plethora of EKGs to practice on, and they'll tell you the answer also. But you can practice on these essentially, and this is essentially they really can't trick you. I mean, you can't trick you with that. And in this video, I'll just review a lot of things that we've said and just pretty much do like a quick review. Now, a quick review of things you definitely want to know is, of course, know all the leads, like lead 1, lead 2, lead 3, blah, blah, blah. AVR, AVL, AVF. Of course, you want to know all those leads, or AVL, AVF. You want to know what they equal, but more, of course, you want, yeah, the angles are important to know because when you do the, I guess the written example, which she gives you a 12-lead EKG, and usually the 12-lead EKG is she's going to tell you like obvious, like, I mean, she tells you what she wants to know. She doesn't trick you with anything. She'll tell you she wants to know the mean axis, the axis deviation. So you'll see your 12-lead EKG. You have to be able to calculate. First, you want to look at lead 2 in AVF, and you want to calculate mean axis deviation by what we did in the video. And then based on the axis deviation, you write it down. And then you calculate the mean axis based on it. And then you need to know the exact angle when you do mean axis. So that's why that circle is very important to know, because you have to know the corresponding negative angles for certain ones. It's easy to remember like 0, 60, 120, 90, 150, all that stuff. 150, yeah, 150, that was negative 150. But you have, more importantly, is knowing how they're formed. Now, on the free written thing, where she says calculate mean axis, calculate axis deviation, and then she'll ask you what is wrong with the heart, which is just saying if it has left ventricular hypertrophy, right ventricular hypertrophy, enlargement, etc., or maybe nothing's wrong with the heart. You just say nothing's wrong with the heart. But I found out she wants to know you know what you're talking about. So if you just if you, based on all the problems that can be wrong with the heart, left ventricular 2 enlargements and nothing, that gives you a 5 option. If you just guess, you have a 20% chance of getting it right. So she's not going to take you just guessing as an answer. So if you just write right ventricular hypertrophy, yeah, right ventricular hypertrophy, or we'll say more common one, left ventricular hypertrophy, and you happen to be right, you still won't get the answer right. Because she wants to know that you actually know what you're talking about, and you didn't just like guess out of nowhere. So you have to write left ventricular hypertrophy because V6, V5, whatever, and write the criteria for it. So know the criteria, watch the video because the video goes over the criteria, or look at your study guide or notes or whatever. It goes over all the criteria. Again, this doesn't trick you. It's there. You just have to know the material. Another thing, definitely, there'll be some simple questions by saying like, what are the limb leads? What are the extremity leads? Limb leads is the same exact thing as extremity leads. Don't be tricked by it. That would probably be a multiple choice because it might be a free response. You never know. But again, just limb leads mean the same thing as extremity. But what I would see the more important one being asked, because the tricky one, that's pretty simple. And saying what are the chest leads and what are the precordial leads? That's a pretty simple question. But saying what are the bipolar leads and what are the unipolar leads, because that's not really common sense. You know, if it says what are the chest leads, saying the leads on your chest, that's kind of common sense. But saying what are the unipolar leads, you wouldn't think about that off the top of your head. So that one you would have to know. Or what are the bipolar leads? Again, simple one, know what the EKG waves are. If you don't know what they are, you're probably screwed by this point. Or when you take the test, like the P wave, the T wave, the QRS segment, be able to identify like the PT set interval, PT segments. Let's just do a very quick review on that one. But okay, EKG, you got the P wave, line, QRS, line, T wave. So like I said, this is the P wave, P. This little guy is the QRS complex. This little guy is the T wave. Know what they identify. Like the P wave will be atrial depolarization. I'm not going to write it. T wave is ventricular repolarization. QRS is ventricular depolarization. Ventriculars are massive compared to the atrium. That's why the amplitude is so much larger in the QRS segment. T wave is the QRS segment recovering, repolarizing, and atrial repolarization is hidden in the QRS segment. Now, this can get tricky with questions saying, now there wouldn't be a question like saying, what does a Q wave represent? Because I don't think that's gone over in the book. That's more advanced cardiology that they don't really explain, because it's really not that important what the Q wave represents. But the Q wave represents the depolarization of that septum in the middle of the heart. But again, that's not really important to know because it doesn't affect anything. Some people have it, some people don't. Now, if it's extremely large, if the Q wave is extremely large, you'll find out in the third test that signifies someone had a myocardial infarction in the past. But as of now, who cares what that means? Know how to name a QRS segment, like the first wave is the R wave, the first wave going up is the first wave going down is the Q wave, then you got the R wave, and the S wave was the second wave going down. And how to name them if it's like this, or if it's like this, that's just look at the book for that. I don't know how it gets more simple than that. Look in the book. It's a simple There's a page in a book that defines what all these are. Like this is a QRS segment. This doesn't go down, so there's no Q, but we got the RS. This is named a little different. Don't quite know off the top of my head right now, I'll admit that. But look in the book, and the page defines all those things. And if that is a picture, that could be a multiple choice, or it can show you a picture of it. It can be either or. Let's see what else we can go over. Oh, the segments. The P wave, you got a segment, blah, 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 T wave. Okay, so you know I named the waves. This would be an interval. Intervals means they include a wave. Segments mean they don't include a wave. It's just a flat line pretty much. So but more importantly than knowing what a segment is and what a interval is being able to define them. Like this would be the ST segment because it goes from the S wave to the T wave. This would be the PR segment because it goes from, is that right? Yeah, that would be the PR segment because it goes from the P wave to the R wave. But more importantly, but you have to know what they are. Like an example would be saying, what does the ST segment represent? It represents the end of ventricular repolarization to the beginning of ventricular depolarization. Because ventricular depolarization ended right here, and ventricular repolarization started right here. This represents the end of atrial depolarization to the beginning of ventricular depolarization. And I don't know if you have to know the common times for the PR segment and the ST segment yet, because I don't know if you've gone over that in the first test, but that's more gone in the arrhythmias about bundle branches and AV blocks and delays and everything. But there's a certain time that most of these should be between to be considered normal. I believe this has to be below than 0.12 seconds. I'm not quite sure off the top of my head because it's been a while since I've looked at the exact times. Calculate heart rate, always count. Anything about heart rate, whenever you calculate heart rate, whether a client is sitting, exercising, or on an EKG, always start with 0. If you don't start with 0, you lose points. Grab someone's wrist between their brachial artery and the thumb and start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously, if you count on EKG, doing the little box method and the big box method, where you count the boxes, you count the little boxes or the big boxes, and you divide by either 300 or 1500. You obviously don't start with 0, but actually, you're not going to be calculating on rhythm strips yet. Let's see, mean axis and axis deviation, I think, is the hardest topic to understand, but I didn't explain it in this video or in this series, but for mean, or maybe I did, I don't know, it's been a while since I watched the first video. But mean axis and axis deviation are, if you understand what they mean instead of just saying it's a range, it makes much more sense to understand what they mean. It's pretty much saying the electrical signal, instead of going from the right atrium down to the left ventricle like it should, because the left ventricle is what's contracting the blood flow, that's where the active potential should be going. What this is saying is, for some reason, either from high blood pressure or mostly high blood pressure, because most Americans have high blood pressure. From high blood pressure, the angle is moving. It's still causing the left ventricle to contract, obviously, but the angle, either from increased muscle mass or increased chamber, is causing the angle to move in a different direction, either going to the right deep axis of the heart, which is going kind of into the, gotta do a little orientation, gotta go into the right ventricle, the left atrium. Is that right? No, sorry, it's kind of going into the right ventricle. Or maybe the axis is going into the right atrium, going completely backwards for some reason. That would not be good. There's nothing that can justify, in a healthy individual, the angle going backwards. Or maybe for some reason the electrical angle is going into the left atrium. Again, that's not really normal. That's mostly from high blood pressure, extremely high blood pressure, where the walls of the left ventricle are so big, they're propelling or pushing the angle to the left atrium. So the angle is kind of going like this. I'll do enough of that. Draw a heart rate here. The angle should be doing this, but say for some reason the walls are so damn big because of high blood pressure that's gone uncontrolled for years, the angle kind of does this. Clearly the left ventricle still contracts, but the angle, it's not normal. It's not healthy for the body. So pretty much that explains mean axis deviation, blah, 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 and you know how, and identifying and electrical stimulation. But the best advice that I can give is obviously watch the videos, because the videos go over it. It's from someone who's taken the class before and knows this material and teaches it regularly. So take the advice from someone who knows what they're talking about. But another thing that I did was use YouTube, use Google. People say Wikipedia is not a reliable source of information. Well, yeah, they're ignorant and they don't know anything, because Wikipedia is pretty damn reliable when it comes to medical knowledge and stuff like that. Because no one goes in there and changes medical knowledge. And have you tried to change Wikipedia? It's impossible to change because it gets changed right back. But anyways, that's pretty reliable information. Of course, Wikipedia goes into much more detail than you need to know about things. But just Google like mean axis deviation practice or YouTube mean axis deviation. How is it found? Or yeah, you can easily find these things to practice on Google. You can find a plethora of EKGs and all these EKGs of people unhealthy and whatnot, but essentially use Google. It's a great source of information. Okay, that's pretty much the video series, and this review was pretty much longer than all the videos combined.